All right, boys and girls, on this video, we're going to look at two different types of fractions that are going to pop up. You should already know these from fourth grade. They should have popped up last year, probably when you were doing some addition or subtracting with fractions. And so we're going to talk about mixed numbers and improper fractions. So on this first page, there's going to be a definition for a mixed number. It says a mixed number is made up of a whole number and a fraction. And so in this particular example, they've given you a picture to look at, and they have also put it there, as far as what it looks like on paper or how you would write it out, which is 2 1/2 is how you would read it. Or you would just write it as in 2 1/2, and that's what they have there on the page for you already. So I'll circle that part. So they're not too difficult to understand what they are. I think probably the hardest part is going to be the math behind these and how we use them in fifth grade. And so, and again, I think there's a really good chance that maybe you've already seen this. And if you have, that's awesome. If you haven't, then it's not the end of the world. You'll learn it now, and it'll be hopefully a really easy skill for you. So that's one of the ones we're going to look at today. The second one that we're going to look at is called an improper fraction. So an improper fraction, it says the numerator is greater or equal to the denominator. And so here they've given you an example, kind of like before. They've given you 5/2. So they have a picture there, and they have it broken up into 5/2. And so, and that's how you would read it. You would not read 5/2. That's not how you would properly read a fraction. If there's a 2 in the denominator, you would read that as 5/2. And so again, understanding what it is, probably not going to be that difficult. How we use it in fifth grade might be the trickiest part. Okay, so what I'm going to now look at with you guys is what we do in fifth grade, or what we sometimes have to do in fifth grade with mixed numbers and improper fractions. This picture really does a good job showing what we have to do with it in fifth grade, and that is sometimes we have to look at one or the other and find, well, what is it equivalent to? So in other words, you have to know, well, if there's a mixed number, there's going to be an improper fraction that it's equal to, or vice versa. If there's an improper fraction, there could be a mixed number that it's equal to, or not could be, there is. And so this particular example on the picture is showing that 1 5/8 is equal to 13/8. And they do a good job there because they've shown a picture of it to describe really what you're seeing. You're seeing one whole, that one whole circle there is 1. And then you're seeing 5/8 of the next circle. Or if you really just go count all the blue, it looks like a pie to me. If you were to go count all the blue pieces of pie, there would be 13 of them. Well, there's 13/8 though, because they're cut into eighths. What I'm going to do on this page is I'm going to show you mathematically how to change one to the other. Now, I said an important word there, and that word is change. A probably even better word that you're going to hear from your teachers is the word convert. Really what you try to do with these is you try to convert one to the other and vice versa. So I'm going to show you here how to convert. On this particular page, we're going to start with converting a mixed number to an improper fraction. So I'm going to show you what I mean by that. So I'm going to use the same one that they use. They use 1 5/8. And what I want to do here is I want to show, okay, well, how did they get that 13/8? Well, they got it because they have a picture drawn out. And that's great, and there's nothing wrong with that. But I think if we're being honest with each other, not everybody is the best artist, and pictures can sometimes get a little bit hard to read and hard to understand. So even as teachers, anytime we stop drawing pictures for fractions, I usually goof on mine, and I'm just like, oh, I can't do this. Well, it's good to know how to do it with a picture, but I think it's even better how to do it, or to know how to do it mathematically with basically pencil and paper. And so what I'm going to show here is how would you change that 1 5/8 to 13/8. And so this is how I teach it. So the very first thing that I always go over with my students is on this lesson, so almost like anything that you're doing for this, remember this: the denominator will stay the same. Okay, so you're wanting to keep the denominator the same. So in this case, it's almost like, okay, well, if that's the case, then I can go over here to my answer and I can say that it's automatically going to be eighths, which is true. We want the denominator just to stay the same. So if you understand what we're doing here, we're trying to turn 1 5/8 into an improper fraction. Well, an improper fraction is just a fraction. It's got a numerator and it's got a denominator. Well, hey, we already got the denominator. We're halfway there. So I think this next part is pretty easy. A lot of times kids, I would say get this down pretty quick. Probably just take a couple examples and they've picked up on it. But you still got to know how to do it. And so I'm going to show it. This is what I teach my students. I call it the circle method. I don't know. That's what I call it. I guess there's kind of a circle here that we're going to do, but I'll show you what I mean. So you're going to start with your denominator, and you're going to kind of just go in this circular motion. Well, as you go in this circular motion, your math that's taking place really is just two math problems. You're going to multiply first, and then you're going to add second. So if I start with my denominator, I'm going to do 8 times 1. Again, I'm kind of following in a circle here. 8 times 1 is 8, and then 8 plus 5 is 13. And that's how I get my 13/8. It's really, really simple. Now, just to clarify, all we did was we just did two math problems. We did a multiplication problem, we did an addition problem. And so now I've got this improper fraction of 13/8, and I'm done. I've found my equivalent kind of counterpart to 1 5/8. So again, you got to keep in the back of your mind what we're still talking about and learning about. We're still learning about equivalent fractions, things that are equal to one another. And this explains it over here on the side. If I were to draw it out in a picture, 13/8 is the same thing as 1 5/8. And so now it's kind of like, okay, well, if I can do that, and I'm looking at, I'm kind of looking at my picture here to think, okay, well, there's my proof. To me, though, the math that I showed you on the circle method, the math is really easy. And so a lot of times that math will get you by, and you don't have to draw that picture. So I'm going to show another one here I don't have a picture of, but it's just another example of one. So let's say we have the mixed number of 3 and maybe 4/5. So 3 and 4/5. And I want to find the equivalent, so I'm going to put an equal sign, the equivalent improper fraction for that. So I'm going to go ahead and draw a fraction bar, and I'm going to start the same way I did the last one. Remember, the denominator never changes, so I'm going to keep fifths for this particular problem. And what I want to do here is I want to think, okay, if I'm going to keep fifths, I want to go back to that circle method, and I want to go in this circle here, and I want to do two problems. I want to multiply, and I want to add. All right, let's follow it. 5 times 3 is 15. 15 plus 4 is 19. All right, I've got now 19/5. 19/5 is equivalent to 3 and 4/5. And so, pretty simple. Don't have to do much else other than that. I could draw it if I needed to or wanted to. I'm not. That would be an ugly drawing, but I could, and I could prove that those two are the same thing. All right, so on this particular page, they've given another example of a improper fraction and a mixed number. This time, though, I'm going to flip it around. I'm going to change, or excuse me, I'm going to convert, better word there, convert. I'm going to convert an improper fraction to a mixed number. And so this one here tends to be a little bit more difficult, and I think it's just because there's some new to it, and I think the new can sometimes throw kids off. But really and truly, I think if you take your time, you'll see it, and you'll see where all the parts and pieces kind of fall in. So this time, I'm going to start with the one that they have on the page, which is 7/4. Okay, what's kind of neat about this one is I can start it the same way I did the last ones. I know in my answer the denominator's not going to change. So I can look at it and go, okay, well, fourths is going to be the same. It's going to be the same answer there. This time, though, I can't really use a circle method. That's only going to happen when you convert a mixed number to an improper fraction. This particular one, I have to think about in a different way. And this is how I teach it. I teach this as basically what you're doing here is you're doing a division problem. And this is going to be kind of weird, but really and truly, this is what this bar means. This bar right here that you see when you write out a fraction technically is a division problem. It's a division symbol. You know, I always tell kids that's kind of weird to sit there and think about it, but think about your traditional division symbol. Kind of almost looks like a numerator and denominator. And so when you're thinking about this, when you're trying to convert improper fractions to mixed numbers, you're basically just doing a division problem. Okay, so this is how I would read this problem. Instead of reading it 7/4, I could read it 7 divided by 4. So I'm going to write that now in a house like you would divide traditionally. 7 divided by 4 would be written out that way. And think about how easy that is. I mean, that's an easy problem to solve. You ought to solve it in about 5 seconds. 4 can go into 7 once. You know that there would be 3 left over. So, all right. So you might be thinking, okay, well, how does that fit into our problem that we're trying to get to? We're trying to get this mixed number. Well, watch, and you'll see all the pieces falling into place. Okay, so we already have one piece of the puzzle. We already have our denominator because it's not going to change. The other things that I need, though, I need a whole number and I need a numerator. So I always like to start with the numerator first. So when you work these, your numerator should be your remainder. So your remainder was remainder 3, so I'm going to have 3 as my numerator. Now I need a whole number. Well, your whole number should be your quotient, or however many times it went in. Well, 4 went into 7 one time, so I'm going to write 1 out to the side, and now I have 1 3/4. 1 3/4 is equal to 7/4. They're the same thing. Well, let's take it a step further and just kind of make it all really start clicking together. Well, think about 1 3/4. If I went in a circle method or you know, kind of use that circle method like before, think about changing it back. Well, 1 3/4, I'm going to keep my denominator. 4 times 1 is 4, plus 3 is 7. There's that 7/4 again. So really and truly, when you're working these, there's not going to be a lot of change that you're going to experience with this. You're pretty much going to do them all the same way. You just got to know how to do it. So again, think about it 2 different ways. If you're taking an improper fraction, like we did on this page, to a mixed number, basically you're just doing a division problem. And kids will ask me all the time, well, okay, so how, you know, if I put up a new problem, well, okay, is it going to, no, it's not going to change. The math's not going to change. The numbers might change, but the math is not going to change. So do them the same way. You know, don't think, okay, well, hey, it's different numbers, so this must be done in this different way. No. The math will stay the same. So use your circle method for one, use your division for the other, and this is pretty easy stuff.